So now we want to start with proof that gamma of 1/2 is equal to square root of pi. We want to prove this gamma of 1/2 is equal to root pi. So this is what we have to prove. What is gamma function? Don't forget, gamma of s, you have to start from definition, is integral from 0 to infinity. 0 to infinity of what? E raised power minus t raised power s minus 1 dt. E raised power minus t raised power s minus 1 dt. So now, that means that gamma of 1/2 will be equal to 0 to infinity, right, of e raised to power of minus t raised to power of what? 1/2 minus 1 dt. So I will have again integral from 0 to infinity e raised power minus t raised to power of minus 1/3 dt. So this is where we are going to make one substitution. So this is by definition. Now I will let t to be equal to u squared. Let t if I let it to be equal to u squared, that means t raised to power 1/2 will be u. So if you exclude the negative sign here, when you exclude the negative sign here, that's where I got my substitution for. And by the time you continue solving and we arrive at our answer, you will see why I use this substitution. So differentiate. This is the substitution I'm going to do. dt will be equal to 2u du. So put it here. Gamma of 1/2 will be equal to integral. When t is 0, u will be 0 as well. When t is infinity, u will also be infinity. So integral from 0 to infinity of e raised to power of minus, this is t is u squared multiplied by t is u squared, that is u squared raised to power of minus 1/2 dt is multiplied by 2u du. So I will have, this will be equal to integral from 0 to infinity of e raised to power minus u squared, right? Square will cancel square root. The square here will cancel the 2 here as well. I'll be left with u raised to power of minus 1. U raised to the power of minus 1 is 1/u multiplied by 2u du. Obviously, u will cancel u and let these two come outside. So that I will have gamma of 1/2 to be equal to integral from 2 will come outside, 2 integral from 0 to infinity. Integral from 0 to infinity of e raised to power minus u squared du. So please, there is something you need to take note here. You need to note that after we are done proving gamma of 1/2 to be root pi, you need to note, because it will be useful later, that integral from 0 to infinity of e raised power minus u squared power s minus 1 dt. So now that means that gamma of 1/2 will be equal to 0 to infinity, right, of e raised to power of minus t raised to power of what? 1/2 minus 1 dt. So I will have again integral from 0 to infinity e raised to power minus t raised to power of minus 1/3 dt. So this is where we are going to make one substitution. So this is by definition. Now I will let t to be equal to u squared. Let t if I let it to be equal to u squared, that means t raised to power 1/2 will be u. So if you exclude the negative sign here, when you exclude the negative sign here, that's where I got my substitution for. And by the time we continue solving and we arrive at our answer, you will see why I use this substitution. So differentiate. This is the substitution I'm going to do. dt will be equal to 2u du. So put it here. Gamma of 1 over 2 will be equal to integral. When t is 0, u will be 0 as well. When t is infinity, u will also be infinity. So integral from 0 to infinity of e raised to power of minus, this is t is u square multiplied by t is u square, that is u square raised to the power of minus 1 over 2 dt is multiplied by 2u du. So I will have, this will be equal to integral from 0 to infinity of e raised to the power minus u square, right? Square will cancel square root. The square here will cancel the 2 here as well. I will be left with u raised to the power of minus 1. U raised to the power of minus 1 is 1 over u multiplied by 2u du. Obviously, u will cancel u and let this 2 come outside. So that I will have gamma of 1 over 2 to be equal to integral from 2 will come outside, 2 integral from 0 to infinity. Integral from 0 to infinity of e raised to the power minus u square du. So please, there is something you need to take note here. You need to note that after we are done proving gamma of 1 over 2 to be multiplied, you need to note, because it will be useful later, that integral from 0 to infinity of e raised to the power minus u square du is actually equal to gamma of 1 over 2 divided by 2. Please take note of this, but let's continue our solution. So I will now do, this is gamma of 1 over 2. That is what we have here. I can also write this u is a dummy variable. That is, I can replace with another thing. I will say gamma of 1 over 2 as well. I can say it's equal to integral from 0 to infinity of e raised to the power minus v square dv. It does not change anything, I just change the dummy variable with respect to the integral. By the time I'm done integrating, I won't see all these dummy variable again. So that is, they are the same. So I will now multiply it. This one multiply this one. That, let me call this 1 and let's call this 2. I will now multiply this multiplied by this gamma of 1 over 2 multiplied by gamma of 1 over 2. That will give me gamma of 1 over 2 all square is equal to this multiplied by this. 2 times 2 will give me 4. I will have integral from 0 to infinity. Another one, integral from 0 to infinity. There are 2 integrals, right? Then I have e raised to the power minus u square multiplied by e raised to the power minus v square du dv. That's what I'm going to obtain. So I will have gamma of 1 over 2 all square to be equal to 4 integral from 0 to infinity, integral from 0 to infinity. This is law of indices, e raised to the power, this one will become e raised to the power minus u square minus v square. And by the time you factorize the minus, you will have u square plus v square du dv. So we want to change this coordinate to a polar coordinate. What's a polar coordinate? It's just a simple substitution. We let u to be equal to r cos theta. Let u to be equal to r cos theta and v to be equal to r sin theta. That's what we are going to have. Let u to be equal to r cos theta and v to be r sin theta. What will be u square plus v square? U square plus v square will be r square cos square theta plus v square r square sin square theta. You can factorize this out as r square cos square theta plus sine square theta. Cos square theta plus sine square theta will give 1. So that means this one will be equal to r squared. So that means u squared plus v squared is equal to r squared. U squared plus v squared gives r squared. So that is what we have here. So again, that means that the next thing I'm going to do now is I will change this du dv. That I will obtain a Jacobian. So to do this, whenever you are dealing with multiple integrals, du dv will be equal to the Jacobian of uv with respect to r and theta. And what is the Jacobian of uv? It means the determinant of u integrating with respect to r, v integrating with respect to r, then the next thing is u integrating with respect to theta and v integrating with respect to theta. I will find the Jacobian of this. So that, don't forget, u is r cos theta. r means differentiate with respect to r. This one will give me cos theta. U theta differentiate with respect to theta. This one will give me minus r sine theta. Then v is r sine theta. R is sine theta, and v theta is r cos theta. So that means that du dv is equal to ur is cos theta, u theta is minus r sine theta, vr is sine theta, and v theta is r cos theta. We will look for the determinants. This will multiply this. I have r cos square theta. I have r cos square theta minus. This will multiply this. I will have another minus r sine square theta. So this one will be r cos square theta plus r sine square theta. This one will give me r. And by the time you get this r, then you should now have the r, the theta here. So that is the u dv. This u dv, when you want to replace it, the u dv will be r, the theta. You first find the Jacobian. The Jacobian will be what will be in front before the r and the theta. So I will find the Jacobian. I have r, the theta. So that's what I have here. That's what I have here. So the next thing I will do is look at it. You know, we have v squared plus u squared to be equal to r squared. We have this. I want to talk about the bound. When u and v are 0, when u is 0 and v is 0, it means that what r2 will be 0. If we put it here, it's obvious. When u is infinity and v is infinity, r will also be infinity as well. It's also trivial from there. R will also be infinity. Now, from here, if I have done u over v or v over u, if I have done v over u, if I have done v over u, let me rub off that side. So v over u will be equal to v is r sine theta and then r cos theta, which will give me tan theta. So it means that tan theta will be v over u. So when u, and the only two values you can obtain from this is 0 or infinity. So no matter the value of u and v you have picked or you have chosen, the value you obtain will either be 0 or infinity. When it's 0, the theta will be 0 as well. And when it is infinity, theta will be pi over 2. So that is the two values. So my point is, I will have integral of gamma of 1 over 2 all square, which will be equal to, this is 4, integral. Instead of writing 0 to infinity, this one, the first one will be for theta. Theta is from 0 degrees to pi over 2. So I have 0 to pi over 2, that's for theta. That's why I found the bound. This for r, I have 0 to infinity for r as well. I have 0 to infinity for r. So I will now have, so this is where I'm coming from. I'm just, before I do this, all this one, the substitution I've made. So I have gone back to the question. I have here 4 integral from 0 to pi over 2 integral from 0 to infinity of e raised to power of minus u square plus v square is r square minus r square. The u dv is r, the r, the theta. So we integrate this with respect to r. By the time we integrate that one, by the time we integrate e raised to power minus r square dot r dr. Don't forget, if you differentiate r square, you will have minus 2r. So this is minus 1 over 2 e raised to power minus r square. Then the bound is still there from 0 to infinity. If you don't understand what I have done here, try to integrate this yourself. Integrate e raised to power minus r square dr. Just make you minus r square. You will see that this is what I have got. You can pause the video and simplify this. This is the substitution you have to make. You will see you will get exactly minus 1 over 2 e raised to power minus r square. Or differentiate this. Differentiate e raised to power minus r square, you will get minus 2r e raised to power minus r square. So the minus 2 multiplied by minus 1 over 2 will give you r. It will give you exactly this. Whichever way is fine, but you just need to understand what I'm saying. So this is what I have. So when you put infinity here, this is e raised to power minus infinity. It will give me 0. This one will become 4. This one is pi over 2. This one will become 4. Integral from 0 to pi over 2. Put infinity, this one will be 0. Minus, put 0. N raised to power 0 is 1. So this one will still give me minus 1 over 2. Just substitute, you will get it, the theta. So at the end of the day, this is what I'm going to have. So I will have gamma of 1 over 2 all square will be 4 integral from 0 to pi over 2. This is 1 over 2 the theta. So the 1 over 2 can come out to become 2 integral from 0 to pi over 2 the theta. If you integrate with respect to theta, you will get theta. This one will be 2 theta 0 to pi over 2. So by the time you put pi over 2, you will get 2 pi over 2 minus 0. 2 cancel 2. So cancel 2, you will be left with pi. So that means that the gamma function of 1 over 2 all square. The gamma function of 1 over 2 all square is equal to pi. Is equal to pi. So take the square root of both sides. Gamma of 1 over 2 is equal to root pi. And that is for gamma of 1 over 2. The next thing we want to do is also example complete the following. Now example. Number 1, compute the following. compose the following. The first thing I have gamma of 4, gamma of 5 over 2, gamma of 4, gamma of 5 over 2, and gamma of 9 over 2. Gamma of 4, gamma of 5 over 2, and gamma of 9 over 2. The second question, gamma of minus 7 over 2 over gamma of 6. Gamma of minus 7 over 2 all over gamma of 6. The third one, C, says integral from 0 to infinity of square root of y e raised to power minus y squared dy, square root of y e raised to power minus y squared dy. So this is the first thing we are going to do. This is what we are going to do for the first one. For the first one, A, gamma of 4, gamma of 5 over 2, all over gamma of 9 over 2. This one will be gamma of 4 is 3 factorial, it's obvious. Gamma of 5 over 2 over. Now, don't forget this formula. Gamma of s is equal to what? S minus 1, gamma of s minus 1. So gamma of 9 over 2 will be equal to 9 over 2 minus 1. That is 7 over 2. Gamma of 7 over 2. So that is this one will be 7 over 2. Gamma of 7 over 2. But 7 over 2 itself. 7 over 2, gamma of 7 over 2 will be 7 over 2 minus 1, that's 5 over 2. Gamma of 5 over 2. So this one multiplied by, this one will be 5 over 2, multiplied by 5 over 2, gamma of 5 over 2. So 3 factorial will give me 6. Gamma of 5 over 2, we cancel this. This one will give me 6 over 35 over 4. The 4 will come up power 24 over 35. I will have 24 over 35 for that. For B, for the second one, gamma of minus 7 over 2 divided by gamma of 6. Gamma of minus 7 over 2 divided by gamma of 6. Now we know what gamma of 1 over 2 is, square root of pi. Keep that. So, but using this expression, gamma of s is equal to s minus 1, gamma of s minus 1. We have proved this in the first lecture. So, gamma of 1 over 2, it means that gamma of 1 over 2, it means that gamma of 1 over 2 will be equal to 1 over 2 minus 1, that will give me minus 1 over 2, gamma of minus 1 over 2. You will continue again. What is gamma of minus 1 over 2? Gamma of minus 1 over 2 will be minus 1 over 2 minus 1. That is multiplied by minus 3 over 2, gamma of minus 3 over 2. If you don't understand what I have done yet, this is what I have done. This is what I have done. So, what is gamma of minus 1 over 2? Using this formula, s is minus 1 over 2. Put it there. That will be minus 1 over 2 minus 1. Gamma of minus 1 over 2 minus 1. If you do minus 1 over 2 minus 1, that is minus 3 over 2. Gamma of minus 3 over 2. That's what we are going to obtain. So that's why I have written gamma minus 1 over 2. Gamma of minus 1 over 2 is minus 3 over 2. Gamma of minus 3 over 2. But I'm going to minus 7 over 2. So this will also be equal to minus 1 over 2 multiplied by minus 3 over 2 multiplied by gamma of minus 3 over 2. You can compute it. but it will be minus 5 over 2. Gamma of minus 5 over 2. Gamma of minus 5 over 2 will be minus 7 over 2. Gamma of minus 7 over 2. So this is gamma of 1 over 2. Gamma of 1 over 2 is root pi. Gamma of 1 over 2 is square root of pi. Minus times minus plus minus plus. So all those ones will be plus. 3 times 5 times 7, that's 105. Is equal to 105 over 2 raised to the power 4, 16. Gamma of minus 7 over 2. We then make minus 7 over 2 the subject of formula. We make gamma of minus 7 over 2 the subject of formula, so that we have gamma of minus 7 over 2 to be equal to 16 root pi all over 105. So that at the end of the day, the second question which says, come back to the question. The question is minus 7 over 2 all over. The question says minus 7 over 2 all over gamma of 6. So this is 16 root pi all over 105 multiplied by 6. Gamma of 6 is 5 factorial. 5 factorial is 120. 4 can go, or 8 can go. 8 can go in 120. This one will give me, no, let's use 4 first. This is 4 root pi over 105. 5 factorial is 120. 120 divided by 4 is 30. So 2 can go again. 2 can go 2 root pi all over 105 multiplied by 15. 105 multiplied by 15, the answer will be 1575. So this is 2 root pi over 1575. So the third one, the third question, C, is saying integral from 0 to infinity of square root of y e raised to power minus y squared dy. Of course, don't forget how we normally approach this question. Let t to be equal to y squared. Let t be equal to y squared, right? So that y will be equal to t raised to the power of 1 over 2. That is what y will become, right? So dy will be equal to 1 over 2 t raised to the power of minus 1 over 2 dt. That's what we are going to have. That is what we are going to have. So when y is 0, t is 0. When y is infinity, t will also be infinity. So I have integral from 0 to infinity. This is y raised to the power 1 over 2. Y is t raised to the power 1 over 2. I will have t raised to the power 1 over 2. Then the square root that is there before, that is raised to the power another 1 over 2. E raised to the power of minus y minus t, because y squared is now t. The y is multiplied by 1 over 2 t raised to the power of minus 1 over 2 dt. Open this bracket. This will become integral from 0 to infinity of t raised to the power of 1 over 4. 1 over 2 is constant, it can come outside. So I have multiplied by t raised to the power of minus 1 over 2 e raised to the power minus t dt. That's what I'm going to have in this case. So I have 1 over 2 integral from 0 to infinity. This is indices. 1 over 4, this is t and t. 1 over 4 minus 1 over 2. 1 over 4 minus 1 over 2 will give you minus 1 over 4. It will give you minus 1 over 4. Minus 1 over 4 raised to the power minus t dt. That's what I'm going to obtain. That's what I'm going to obtain. So this is gamma function. So this is exactly 1/2 gamma of what? Minus 1/4 plus 1. Minus 1/4 plus 1. That will give me, this one will be equal to 1/2 gamma of 3/4. I have not clearly defined what gamma of 3/4 will be or how it can be done. So we leave the answer like this. I want to move to the next thing. So given that we want to move to another example. Given that this example is what connects the Laplace function, the Laplace transform with the gamma function. Given that the Laplacian, this function we have defined for us is Laplace transform function. Integral from 0 to infinity of e raised to power minus st f of t dt. Number one thing they want me to do is that show that Laplace of t raised to power s is equal to gamma of s plus 1 all over s raised to power s plus 1. That is the first thing we want to prove. The second one, hence or otherwise. Compute the Laplace of t raised to power of 7/2. Then C is talking about integral from, we should also evaluate integral from 0 to infinity of e raised to power minus st over root t dt. E raised to power minus st over square root of t dt. So, without wasting time, we compute. I will start from what we are given. We are given that the Laplace of a function f of t is equal to integral from 0 to infinity of e raised to power minus st f of t dt. So, they now ask me to show that. So let f of t be t raised to power n, which means that Laplace of t raised to power s will be integral from 0 to infinity e raised to power minus st multiplied by t raised to power s dt. So let u be equal to st. You know why? You know why I'm making it to be st? Because I want to write it in form of gamma function. So make the distorted of formula t will be equal to u over s. So differentiate the t will be 1 over s du. U is a constant, it's just a constant. So it means that the Laplace, again, when t is 0, u is 0. When t is infinity, u is infinity. So the Laplace of t raised to power s will now be equal to integral from 0 to infinity of e raised to power minus u. No, this is st. E raised to power minus u multiplied by t. T is u over s. U over s raised to power s multiplied by the t. The t is 1 over s du multiplied by 1 over s du. So this will become integral from 0 to infinity e raised to power minus u raised to power s over s raised to power s multiplied by another 1 over s du. Let the constant let the constant come outside. When the constant come outside, you are going to have 1 over s raised to power s plus 1. I have s raised to power s, another s is here, s raised to power s plus 1, integral from 0 to infinity of e raised to power minus u raised to power s du. So at the end of the day, you can see that we are through with what we are looking for. So the Laplace of t raised to power s will be equal to 1 over s raised to power s plus 1 multiplied by, this is 1 over, this is s raised to power s times s raised to power s plus 1. So I will be left with t raised to power minus u raised to power s. This is exactly the definition of gamma function. So this is gamma of s plus 1. This is gamma of s plus 1. And we are through with what they asked us to do. Therefore, Laplace of t raised to power s equal gamma of s plus 1 all over s raised to power s plus 1. Let's go to B. Let's go to B. I'm now told to answer otherwise, evaluate. I'm told to evaluate the Laplace of t raised to power 7 over 2. Don't forget, before I write this, Laplace of t raised to power s is gamma of s plus 1 over s raised to power s plus 1. So now Laplace of t raised to power 7 over 2 just means gamma of 7 over 2 plus 1 all over s raised to power 9 over 2. 7 over 2 plus 1 will always give 9 over 2. So what is gamma of 9 over 2? Using gamma, don't forget, always remember this. S plus 1 is s gamma of s, or you use gamma of s to be equal to s minus 1, gamma of s minus 1. Whichever one you are using is fine and correct. Whichever one you are using out of the two is correct. So gamma of 9 over 2 will actually be 7 over 2, gamma of 7 over 2. That's 7 over 2 times 5 over 2. I hope by now you should have understood what I'm writing like this. 7 over 2 times 5 over 2 times 3 over 2 times 1 over 2, gamma of 1 over 2. All over s raised to power of 9 over 2. Everything here, 7 times 5 multiplied by 3 will give us 105. Gamma of 1 over 2 is root pi. We have proved that already. 2, 4, 8, 16. 16 s raised to power 9 over 2. So that is the answer for this one. Then for the third one, we have integral from 0 to infinity of e raised to power minus st multiplied by square root of t is t raised to power 1 over 2. So when I take it up, I have t raised to the power of minus 1 over 2 dt. And from the definition of the Laplace transform, Laplace says that Laplace of f of t is integral from 0 to infinity raised to power minus st f of t dt. So this means that in 0 to infinity raised to power minus st f of t, that this is exactly the same as Laplace of, this is exactly the same thing as Laplace of t raised to the power of minus 1 over 2. Laplace of t raised to the power of minus 1 over 2. And that means from the definition of gamma, this one will give me gamma of minus 1 over 2 plus 1 all over s raised to the power of 1 over 2, because minus 1 over 2 plus 1 will give me minus 1 over 2. So minus 1 over 2 plus 1 will give me 1 over 2. And what is gamma of 1 over 2? Gamma of 1 over 2 is root pi all over s raised to the power of 1 over 2. Or if you put both of them inside the square root,